Hi, we're Group 16. I'm Jain, and here are my group members Ewan and Weiher. Our topic is AI in predictive analytics for customer spending behavior. Nowadays, rising food expenses, high rental prices, and surging gas prices are just a few economic hardships for consumers. A product's dynamic pricing is important to affect the fluctuation of the product's supply and demand. This will help companies to develop effective pricing strategy. Apparently, companies need to work harder to win over the business of more money-conscious consumers. Hence, we have proposed our research objective to solve the above stated problem. The purpose of this research is to analyze consumer spending behavior for boosting sales and also predict the factors that are likely to influence the customers on joining membership. Next, Ewan will be introducing the methodology for our research.
Research requires us to evaluate the consumer spending behavior that could help company to develop the best pricing strategy. We will conduct this research using the cross-industry standard process or data mining methodology. Firstly, in the business understanding stage, we have identified the business problem, which is the present economic challenges that led to more money-conscious consumers, while the business objective is to understand customer spending behavior and develop effective pricing strategy. During the data understanding phase, we know that the dataset is one of the historical sales of a Myanmar supermarket company which has been recorded in 3 different branches for 3 months. Moving on, we will start with data preparation. During data pre-processing, we will check for any duplicated missing value to be removed, outliers and correlation between data will be identified. In this research, we will be comparing different models by using linear regression, decision tree, and knife bias. In the model selection stage, we will distribute 4 types of data partition of 50 to 50, 60 to 40, 70 to 30, and 80 to 20 respectively. Forward, stepwise, and backward variable selection method are tried on each regression. In the evaluation stage, the best model with lower average square error and misclassification rate will be chosen to be the final predictive model. Lastly, in the deployment stage, descriptive analytic and graphical model will be done by using SAS-EG. A report about our finding and discussion will be generated. Now, I will pass to Wei Heng to continue for the objective and literature review.
Thank you, Ewan. Our first research objective was to analyze customer spending behavior. Linear regression was selected as our approach to estimate the relationship between quantitative variables such as product quantity, unit price, and tax. Moving on, the second research objectives includes in predicting customer decision on joining the membership. Knife bias was selected as the techniques to solve multi-class prediction problem and to evaluate the categorical input variables such as rating and quantity. Decision tree method was selected as another approach to check the significance rate and relationship between variables. This helps in making prediction on categorical target variable. There were 2 literature review case studies that we are comparing and referencing. The first being the Airbnb case study done by Teresa Kayan. The author used 5 different methods to predict the price formation according to the demands of booking rooms, whereas Brenda and et al. Used 5 different methods to determine the right pricing strategies with the aim of increasing ticket sales on the platform and the associated revenue in regards to public transportation. The Lasso survey results of Airbnb showed a mean absolute error of 20 using data partition ratio of 80 per 20, whereas the random forest and XGBoost algorithms in public transport case study showed a 90% accuracy of predicting modeling. If the ticket sales increased by 6%, the company's sales income would simultaneously increase by 9%. I would now pass it on to Ewan for further elaboration on linear regression predicting methods.
For the first part, we used linear regression to analyze consumer spending behavior in order to customize dynamic pricing strategies. The best chosen linear regression model is the one with data partition 7 to 30, where variables are selected via stepwise. Only 2 significant variables entered the model. This proves that quantity is significantly affected by tax 5% and unit price. This slide shows the equation for our linear regression model. We have found out that for every 1 Myanmar kyat increase in tax 5%, quantity is estimated to increase by 0.3 units after rounding up. According to the analysis of variance table, the F-test shows that this regression model is overall significant, so it provides a benefit to the data. Forming the linear regression, it can be seen that there is a relationship between the unit price and quantity. Therefore, we have decided to discover the customer spending habit based on different product lines. It can be concluded that the quantities purchased by customers for products in the categories of electronic accessories, home and lifestyle, and also sports and travel are higher than the other 3 categories, while the unit price range of health and beauty, home and lifestyle, and also sports and travel are on the higher end as compared to the other 3 categories. We have also observed the Pearson correlation coefficient to determine the strength of linear association. All the categories above have weak positive association between unit price and quantity. except for electronic accessories that show weak negative association. This means that consumers are able to accept rises in the unit price for all the other categories except for electronic accessories. If unit price for electronic accessories all the categories, gross income has a strong positive association with unit price. This means that when unit price increases, gross income will also increase. Therefore, companies should pay more attention to the pricing strategy for electronic accessories to ensure that prices do not fluctuate too much to retain customers and obtain sales. That's all from me for part 1. I'll pass it to Ewan to talk about part 2 for our second research objective.
By using Knife-Bayes model as the classification machine learning algorithm, we can predict the factors that are likely to influence the customer joining membership. From the model comparison table, it showed that the HP Bayesian network classifier with data partition 80 to 20 has the best performance. This is because the value of misclassification rate is 0.472637, which has the lowest value compared to other models in the table. The quantity, product line, gender of the customer, the payment method, the branch and city are relevant to customer type. From the table above, we can see the rating is more relevant to customer type because it has the highest chi-square value, which is 8.1544. As we know, the larger the chi-square value, the greater the probability that there really is a significant difference. Thus, there is a significant difference between the target variables. Next, quantity and rating have larger sample size as they have 9 degrees of freedom, which means they have more power to reject a false null hypothesis and find a significant result. Therefore, it can be concluded that high customer satisfaction give a higher rating score and the customer are more likely to register themselves as a member. Based on the event classification table, the Knife-Bayes model ability to find all relevant target is 51% and the precision is 53%. Overall, this model is 47% often to be wrong and 53% often to be correct. That's all for my part, and I'll pass to the next presenter.
The model comparison graph shows decision tree 1 being the best predicted model compared to the other 7 models. The misclassification rate reached 0.4987, which resulted in being the lowest error of predictive modeling. The above graph shows when a male customer is using an e-wallet payment method and spend an average total of 320 in that store, he has a chance of 61.2 probability of being a non-member as shown in note 12. In the other way, if a female customer gave a rating of less than 5.95 and spent less than 320, the model predicts she might have a chance of 64.58% to become a member. The result shows the model will predict the lowest misclassification rate when there are 4 to 5 leaves in this model. Hence, it is best for us to keep 4 to 5 factors in determining if the customer is going to be a member to avoid underfitting or overfitting. At the leaf chart for validation data, Decision tree 6 shows the biggest difference between trained model and validation model. The model showed the lowest leaf value than the other models at 20% of respondents, where it had achieved the highest leaf value when 40% of the respondents were reached. This indicates when we are measuring 40% of the records based on this model, we can expect the consumer might be 5% more likely to become a member than becoming a normal consumer. The decision tree model's ability to find all relevant target is 50% and the precision is 50%. Overall, this model is 50% often to be wrong and 50% often to be right. In summary, the decision tree results implies no significant predicting power to our target variable customer type. Potential interpretation of this scenario may be due to our target variable being hard to assess indecisively and our input attributes may potentially acting weak in predicting our target variable. To conclude our research findings and compare it with previous studies, the previous studies shows an averagely high accuracy of 90% and having low variance between the records. In contrast, our research found the highest accuracy when performing 3 different techniques in predicting modeling was linear regression while having a value of 81.9%, whereby the best predictive model for estimating our second objective, Knife-Bayes, was selected as the preferable techniques in compared with decision tree, as the performance shows a better result. There were 3 limitations we had encountered on this research, the first being lack of performing previous research studies. This leads us to having limited knowledge and access in performing predictive modeling research. Time constraint is another issue that leads us to constantly changing our measurement approach and identifying error for different circumstances. Insufficient sample size for our research is also another huge factor for not achieving a good predictive power and draw valid conclusions on our models. To rectify our problem and aims to propose a better research studies in the future, we target ourselves to perform more intensive literature review in order for us to learn more predictive approaches. Furthermore, focusing more on investing time for studying and performing practical training. This makes us exploring more statistical measurement for future studies and avoiding mistakes. This is the end for the Group 16 presentation. Thank you for listening.